Very good afternoon, everyone. So, I was just thinking about the fact that what should we start doing in this series, and what I've done is that I don't know whether it will help you right now or not, but I have made some precise notes from JD Winder, and this is a chapter called Ignis Structure and Relation. These are very short and very crisp notes that we have, and it will help you to just go through this content and everything. So, starting with the igneous structure and field relationship. So, I'll be covering this chapter in parts. So, okay. So, extrusive volcanic process, products, and landforms. So, first of all, we are studying the extrusive one, and we have the properties of magma and different eruptive styles. So, किस चीज़ से magma viscosity जो है वो control होती है? It's by the composition of silica content, temperature, and crystallinity. Now we have polymerization, that is silica, oxygen, aluminium, oxygen network. Basalts have fewer polymerized chains, that it has lower viscosity, and rhyolitic magma has higher polymerized 3D network, that is higher viscosity. We have mainly volatiles. We have H2O, CO2, S2O, and others as HCl, Cl2, and F2. Eruption styles, for those with low viscosity, they have and low volatiles, they have quite eruptions like quiescent eruption. And with the high velocity and high volatiles, we have explosive eruptions like Karakatu, Mount St. Helens, etc. Volatiles expands as pressure decreases and causing the explosive eruptions. Now we have examples. So Hawaiian basaltic eruption is effusive, forming lava lakes and fountains. Karakatu is tremendous explosion and it is heard almost 4,800 kilometers away, and ash altered global climate. Now we have central vent landforms. So we have shield volcanoes that has a slope of 2 to 10 degrees, and it is a basaltic flow. It flows from over the hotspot, that is Hawaii, Mauna Loa, and Mauna Kea. It is intraplate, and it has a large size up to 40,000 kilometer, and it has long lava flow distance like Pele here kind of thing forms over here. Now we have composite volcanoes, that is stratovolcanoes. They are steep side cones and it has a slope up to 36 degrees, and it has a common magma called andesite. Alternating pyroclastic and lava deposits are there, and Mount Fuji and Mount St. Helens. These are example of that, and इसी से ही इस वाले पेपर में एग्जाम्पल आया था कि माउंट फ्यूजी जो है वो किसका एग्जाम्पल है. Parasitic cones, flank eruptions, ठीक है. Complex history involving eruptions, destruction, and rebuilding. Now we have smaller forms like cinder scoria cones, and it is composed of ash lapilli blocks from the weak explosive activity. It has a small size, less than 300-meter high and 2-kilometer diameter. Project Paricuta in Mexico is the example. Now we have Mars. Mars are the craters that formed by the magma groundwater interaction, that is phreatic explosion, saturation zone. Basically, larger craters with low rims, tough rings, and tough cones. This results from the magma water interaction forming layered pyroclastic material. Tough rings are low rims, and tough cones are steeper side with smaller craters. Now we have domes. They are degassed, viscous silicic magma, dialite or dacite, and they have characteristic of being rough and have brecciated surface. Tallest appearance at the base. Variants are cryptodomes like inflated below ground, etc. And it's just domes below ground are known as cryptodomes. Cauli are flattened domes with falling flowing downslope. Now we have calderas. Calderas are the large depression that has been caused by magma chamber collapse after the massive eruption. The Yellowstone crater lake is the example of it. Now we have intrusive plutonic process and structures. We have typical shapes of plutonic bodies like dikes and sill. Dikes are steep sheet-like intrusion that is cutting across the bed. If these are the bedding, so this is a dike, and sills are horizontal one, and it is the vertical one. ठीक है. Dome shape intrusion with a flat base, uh, like this. And we have batholith. They are the large irregular plutonic body forming by multiple intrusions over time. Now we have contact features with the ball rock vary with the depth of intrusion and size of pluton. Metamorphic effect, there are high temperature aerols called hornfels and skarns, and fluids movement along the contacts can deposit minerals. Now we have pluton emplacement and space creation. So we have stopping, country rock block falling into magma and melt. Lifting, overlying rocks are pushed up, and assimilation, incorporation of surrounding rock into magma. Now we have outcrop scale features. So we have volcanic rocks. So vesicles, gas bubbles have been trapped in cooled lava. Scoria is basaltic, highly vascular. Pumice is rhyolitic, that is frothy glass. So scoria is basaltic, you need to remember that, and pumice is rhyolitic, and amygdaloid vesicles जो कि secondary minerals से fill हो जाते हैं जैसे कि opal and calcite. So if someone says ask about कि भाई amygdaloid क्या है, तो वो opal and calcite जो है आपके secondary आपके vesicles को fill कर देता है, तो वो है. Plutonic are the chilled margin, fine grained edges due to rapid cooling against cooler rock, and xenoliths are the fragment of surrounding rock that have been trapped in the magma. So chilled margins क्या होते हैं? Fine grained edges होती हैं due to rapid cooling against the rock. So we have magma viscosity, we have low basaltic and high rhyolitic, dacitic. In explosive and effusive में फ़र्क है. Volatile content low होता है, high होता है. And examples Hawaiian and Mount Helens and Karakatu. And landforms are shield volcanoes, domes, and composite volcanoes and calderas like Mount Fuji is example of it. Now we have on the notes only fissure eruptions, lava flow features, and pyroclastic deposits. So we have fissure eruptions. So definition: fissure eruptions occur when magma erupts along the fractures of sets of fractures rather than from a central vent. These factors as planar conduits with a solidified magma known as feeder dikes. Now characteristics: they occur on a central flanks of central vent in regions of undergoing regional extension is there. Okay, there are the fissures formed. African Rift Valley, basins and range, Iceland, extensional bases behind volcanic erosion reveals feeder dikes, which can form concentric radial and parallel structural patterns. Types of fissure eruption: we have subaerial, so they have been seen in flood basalt province, that is Columbia River basalt, and large eruption displays crust and forming structural basins. Submarine fissures are formed around the mid-oceanic ridges, mobs. They create the most of the Earth's ocean crust, only visible above sea level in Iceland. So we have lava flows. Lava flows characteristics: so quieter than explosive erosion but dominate Earth's volcanism. They are common in low viscosity, low volatile content. Example basalt. The types of lava we have pehoho. Pehoho has smooth and ropey texture like flow increases basalt composition में. So they form low viscosity basalt and often near vents. AA are rough, clinkery texture with scoriaceous rubble, and they form as lava cools, thickens, and break apart into blocks. So lava may transition from pehoho to AA as it cools, flows away from the vent. Inflated lava flows are something that have been observed in basaltic flows, example Hawaii and Origin, and they begin as a thin flow and inflate internally up to 18 meters as lava accumulates beneath the crust. Now we have flow types by composition. Basaltic flows are thin, extensive, fast moving. Andesites are viscous, they form blocks, steep fronts. Dacite and rhyolite due to high viscosity, rare due to high viscosity and explosive nature, they form domes and thick flows. Now pillow lavas form when the lava enters the standing water, creating rounded blobs-like structures. They are surrounded by the fine glass debris, haloclastite and palagonite. They are basalt surrounded by. So basically about the pillow lavas, they form when the lava enters the standing water. So they create this blob-like structures, and they are surrounded by fine glassy debris called haloclastites. I've told you. Columnar jointing is formed due to the contraction as lava cools, and these polygonal columns, they typically have this 5 to 6 sides, and they are common in basalt flows. About the pyroclast deposit, I will cover in the next video. So with this, I will end this video. Thank you.